Dear students, in this class we will be having class on symmetry and skewness. Actually this is the last topic in the first unit, okay, in the descriptive statistics unit. This is the last topic we are going to have. So first I will tell you what do you mean by symmetry. Okay, it is an attribute, it is a character to describe the data distribution, to describe graph of data distribution. When it is graphed, see, when it is graphed, actually we are going to talk on graph first of all. So we are going to talk on graph first of all. So when we say that graph is symmetric, it can be divided at the center so that each half is the mirror of the other. So normally it is the original meaning of symmetric. When I am giving you example, you can understand very clearly. So when we look at the graph, exactly at the center point, left half and right half area will be same. Both are equal. So in that case, we will say that data distribution is symmetric. Otherwise, normally we will call that is asymmetric, and we will move on to skewness. If the given data is symmetric, we will not talk about skewness. So now you can understand, you see first graph, this is actually graph. Why I am telling this is symmetric graph? I am having a center point line. So left and right side area both are equal. You can understand, you see this area are equal. Having a data, if you are having a data, if that data gives you this type of graph, like left half is the mirror of right half, then we say that that graph is symmetric. Data distribution is symmetric. So we are talking on data distribution. In graph we will call is symmetric when if left half is equal to right half of that graph. Here also you see this also a symmetric graph. Why? Because the left side area is equal to the right side area. If we fold exactly at the center point, if we fold like this, the area will be matched, okay, the graph will be matched. So in that case we will call this one as symmetric graph. You see, a distribution is symmetric if its left half is a mirror image of right half, then we say that symmetric graph. Now you can understand symmetry in a clear way. Actually this is one type of graph is there. What type of graph? In your syllabus we are having three type of graph: histogram, frequency polygon, and ogive graph. Here this one is histogram graph. So I am going to explain in histogram graph. Histogram graph. So in this graph, if you draw one center point, okay, which means mean point, if you draw one center point, left area is the mirror of right area. You can understand clearly. One more important point, okay, if we are having a symmetric graph, okay, you see this is like frequency polygon graph. One more important point, if we are having a data distribution is symmetric, if we are having a symmetric data distribution graph, then definitely we can say all measurement of central tendency equal. All measurement of central tendency are equal. You see, what are all the central tendencies? Mode, mean, and median. You know how to compute, how to find the mean and median and mode value if we are given a data. So if we are given a symmetric data distribution, definitely we will get the answer mean is equal to mode is equal to median. So this is one of the most important point, skewed distribution, okay. So just now I have completed when we say that a data distribution is a symmetric distribution. If it is not a symmetric distribution, we are going to discuss about skewed distribution, right. If a given data distribution is not a symmetric, then definitely it will be a skewed distribution. You see, a distribution is said to be skewed if mean, median and mode fall at different points, which means it will not equal. Okay, it will not equal. That is mean, median, mode not equal. If you are getting mean not equal to median not equal to mode, then definitely that given data is belongs to asymmetric type, right? It is not a symmetric type, so it is belongs to skewed distribution. So there are two type of skewed distribution. So one is left tailed, normally we will call that one as negatively skewed, okay, and the other one is right tailed distribution, okay, we will call positively skewed distribution. So there are two types. First I am going to explain about left tailed skewed distribution. Okay, you can understand by looking at the graph. You look at the graph, you can understand. So we are having one histogram graph. X-axis is some measurement. Y-axis normally we will denote that one as frequency. So in this graph you see definitely it is not symmetric, that you can understand easily. Definitely it is not symmetric, since we are not having a center point such that left side area is equal to right side area. So we don't have that kind of graph. So definitely it is going to be graph. Okay, so definitely it is skewed graph. Whether it is positively skewed or negatively skewed, that means whether it is left tailed or right tailed. So in the left tailed distribution graph, you see the left side, right? You will have the long tail. You will have the long tail in the left side. Okay. In the right side, you will have a short area only, right? You will have short area. That's why it is called left tail, right? Most of the points, most of the data points has been spread out in the left side only. Has been spread out in the left side only. Okay. Even though we are having peak here, most of the data are spread out in the left side, which means it has long left tail. That's the reason why it is called left tailed distribution. So it is an example in histogram graph. You see here also it is like frequency polygon graph. Here also you see a long in the left side, okay, a short side, a short tail in the right side. That's why it is called left tailed frequency distribution. And one of the relationship in symmetric graph, what is the relationship we are having? Mean is equal to mode is equal to median, right? Mean is equal to median is equal to mode. But here we will not get equal values, equal measurements. We will have mean is less than median, less than mode, right? In that way we will get the answer that we will discuss later. Now you understand. So this is an example for left tailed graph. So a distribution is left skewed. We will call normally the other name also is there, negatively skewed. Okay, left skewed, negatively skewed, both are same. Okay, if the values are more spread out on the left. Okay, if it has the long tail in the left side, then we will say that corresponding distribution is left tailed data distribution. Now right skewness. Okay, when we say that a data distribution is right skewed or positively skewed, if the values are more spread out at the right, then we will say that the corresponding data distribution is right skewed or positively skewed. Okay, you can understand by looking at this example. First you look at the histogram graph. Look at the histogram graph. You see here you are having long tail in the right side. You are having the long tail at the right side. Okay. Even though we are having peak values at the left side, we are having long tail at the right side. That's why it is called right skewed. Okay. Right skewed or positively skewed. So we are having the values, the data values are spread right side more. Right side it has been spread out more. That's why it is called right tailed. Here also see tail in the right side. So it is called right skewed or positively skewed. Okay. So in this, what will be the relationship you will get? What will be the relationship you will get you can understand mode value is less than median values is less than mean. Just opposite to the previous relation. There we will get mean value less than median value less than mode. Here we are getting mode value less than median value less than mean. Always median is going to be our middle value in this relationship. Okay, so no doubt on that. Always median is going to be middle value in this relationship. So we are going to check whether is mean is less than mode or mode is less than mean. Okay, if mean is less than mode, left skewed. If mode is less than mean, then right skewed. Okay. Okay, so we have explained. I have explained a symmetric distribution and a skewed distribution. Okay. So skewed distribution means there are two types, positively skewed and negatively skewed. Now we are going to measure that deviation. Anyway, skewed means some deviation. Okay, it has a long right tail. If we are having right skewed distribution, it has long left tail if it is left skewed distribution. Now we are going to measure those values. We are going to measure those values, that is the skewness. We are going to measure the skewness. Okay, we are going to measure the skewness. Okay, how we are going to measure the skewness? Actually, the full name is Karl Pearson coefficient of skewness. That mathematician has found that formula. Okay, Karl Pearson has found the formula. That's why the name of that measurement is Karl Pearson coefficient of skewness. So what is the formula? Based on mean, mode and standard deviation, we are going to calculate the Karl Pearson coefficient of skewness. So what and all the values we need? Mean, mode and standard deviation. Mean, mode and two measures of central tendency and one measurement from deviation. We are having two type of deviation measurement in your syllabus, mean absolute deviation and standard deviation. In that we are going to use standard deviation. And we know the relationship between, we can write mode values of median and mean also. That is one more relationship is the median minus 2 into mean. So by using that we can write formula. You can write another formula. 3 times of, you can take 3 common, you can add these 2 mean plus 2 mean and 1 mean, you will get 3 mean. So 3 times of mean minus median by standard deviation. So this is another example. If you know mean, median, standard deviation, you can use this formula. If you know mean, mode and standard deviation, you can use this formula. So you can use either formula to find the skewness of a given data distribution. And one more note is there, important note. You may expect this note in one more question. The value of skewness, the value of skewness lies between -1 and +1. The value of skewness lies between -1 and +1. So if you are getting negative value, you can say that given data distribution is negatively skewed. If you are getting positive value, then we can say that the data distribution is positively skewed. If we are getting 0, okay, if we are getting skewness value is equal to 0, then there is no long tail in either side. You are getting a symmetric, okay, you are getting a symmetric graph, okay. Left half is equal to right half area, okay, if we are getting skewness value is equal to 0. So value lies between -1 and +1. If its value is 0, then there is no skewness. Now we are going to find that coefficient of skewness for the following data. For the following data, we are going to find the coefficient of skewness, which means Sk we are going to find. We are having two type of formula by using mean, mode, standard deviation, by using mean, median, standard deviation. You can use either one formula. And if you are looking at the data, I told you, you have to confirm that whether it is raw data or frequency data or class interval data. For all the type of data, you should know how to find all the measurement like mean, median, mode, mean absolute deviation, standard deviation. Okay, so first you have to look at the data, which type of data is given to you. Now look at the data, which type of data is given to you. This is like frequency data, not class interval data or not a raw data. It is frequency data. So x values and f values are given to you. Now I am going to find the SK value, I am going to find the skewness value, I am going to find the Karl Pearson coefficient of skewness. What and all I need to find the SK value? I told you I can use either formula. Here I am going to use this formula. Here I am going to use this formula. Mean minus mode divided by standard deviation. Mean minus mode divided by standard deviation. So what I need? I have to find mean and mode and standard deviation. So three measurements I have to find for the frequency data. So you should know all the first unit measurement, then only you can find this Karl Pearson coefficient of skewness. That is more important. So you know how to find mean for frequency data, you know how to find mode for frequency data, you know how to find standard deviation for frequency data. Okay, so in a single table I am going to explain you, I am not going to explain in depth. You know how to calculate all these measurement, so I am going to explain briefly. You see, first I am going to find the mean value. First I am going to find the mean value. What I am going to use here shortcut method. Okay, so there are three type of methods. There are three type of methods: direct method, shortcut method, and step deviation method. Here I am going to use shortcut method. For that I need assumed mean. For that I need assumed mean. You know how to assume this mean, okay, by finding the average. Finding the average, which one is near to the average is assumed mean. Then you write all frequency. Then you use the assumed mean to find the deviation from each and every value. What is the deviation from that assumed mean? X minus 9. Okay, x, normally the formula is x minus a. So you find all the values, which means here x is 6 minus assumed mean is 9. So you will get minus 3. Then here 7 minus 9, you will get minus 2. So this way you calculate all the value, all d for each and every x, you find d. Then in the formula you need fd. You multiply fd, corresponding fd, right? First row f is 3. First row d is minus 3. So you will get minus 9. Second row f is, second row d is minus 2. So you will get minus 12. So in this way you calculate fd. We need fd square to find the standard deviation. Okay, we need fd square. So within a table you find all the requirements. You find all the requirements. Then you can substitute in each and every formula. Don't form another table to find standard deviation. You find all the whatever you need. You find in a single table. That will be useful. So fd square, which means f into corresponding deviation square. F into corresponding deviation square. Don't think it is fd the whole square. It is not correct. F into d square, and then cumulative frequency. Okay, cumulative frequency, you add step by step the frequency value, then you will get the cumulative frequency. So now I am going to apply in this formula. Mean is a plus summation fd by summation f. Every values are there. A is assumed mean, summation fd is addition of all fd, and divided by summation f is addition of all frequencies. So what I am getting? 9. Mean value is 9. And mode, there is no formula to find mode here. Mode, what is the definition for mode? The most frequently occurring x value, right? Most of the time occurring x value. What value is occurring most of the time? You look at the frequency and the value. 6 times, so 13 times, okay? 9 occurred 13 times, which means 9 occurred most of the time. So that is going to be the mode value. That is going to be the mode value. So mode value is 9. Mode value is 9. Then finally standard deviation, square root of summation fd square by summation f minus summation fd by summation f the square. So after all substitution, what I am getting? 1.61. Now what is the formula? Karl Pearson coefficient of skewness formula. This is the formula, mean minus mode divided by standard deviation. You substitute 9 minus 9 divided by 1.6. What I am getting? 0. So what I am getting? Karl Pearson coefficient 0. So what is the meaning of this one? What is the meaning of this one? Given data distribution is symmetric. There is no skewness in that data distribution. Okay, there is no skewness. So if I am getting negative value, negative skewed. If I am getting positive value, positively skewed. Here I am getting 0. So there is no skewness. I am getting skewness value is equal to 0. Okay, so in this way you can understand the skewness. So you practice this problem. Okay, you practice this problem. This problem belongs to class interval data. Okay, only one more column additionally you are going to have. You have to include one more column in the table. What is that column? You have to find the middle point x. Okay, you have to find the mid x. Since we are given class interval, you have to find the middle value for each and every class interval. That value is going to be x for you. Then frequency already it is there. Then you can find each and every value, like in the previous problem we did. You can refer that problem to find the Karl Pearson coefficient of skewness. So that's all. So if you are having any queries, if you are having any doubt, you can contact me. So this is my phone number and this is my email ID. So if you are having any doubt, please contact me. Thank you so much.